Hey, and welcome everybody to the live stream today about firefighting foam and the human and environmental impact. I want to welcome to the stage today Dave Ramsey. Dave has been kind enough to give us half an hour of his time, probably a little bit more in preparation. But first, by welcoming you, Dave, tell us a little bit about yourself and your role within Johnson Controls.
Okay, thanks, Russ, and thanks for giving us the opportunity. So I work for Johnson Controls. I've been, which started out as Tyco for the last 16 years. I've actually been in the fire protection industry for about 43 years, which is a bit hard to believe. Started out working for a fire protection contractor for about 20 years, then moved into different areas of design, estimating, project management. So my current role with Johnson Controls is the foam and foam hardware sales manager, and my region is to look after for the whole of APAC. So looking after the Ansell, ChemGuard, Scum and Sabo brands of firefighting foams and hardware. So
you've been involved in the fire industry for, I think your bio with me said 43 years. And I'd imagine that you've done quite a range of different things over that time.
Yeah, it's hard to believe. I'm sure you're thinking, oh, he must have started when he was a 10-year-old. But now with a sprinkler contracting company for 20 years, and mainly in the design side of it, and then in products. So I've had a good spread of experience, I suppose, in terms of the special hazards products, looking after the gaseous suppression systems, kitchen systems, vehicle systems, and sort of more recently the foam and foam hardware. In the sprinkler contracting company, which is Walker Fire, or Thomas Walker as it was at the time, pretty well worked through all different areas of, started out as a trainee draftsman, then worked through to estimating, project management, and ultimately sort of some management roles. So it gave me a good sort of grounding for the seeing how the contracting side works, and now I've come across into the product manufacturing side, which has been great.
Before we duck in too far, I just wanted to just say that this video, there is a bit of a disclaimer, and we're going to talk about some things. And what we really want to assure people is that they need to take their own counsel and advice in respect to the matters that we're going to talk about. So there is a bit of a disclaimer. So let's just have a quick look at that. So this is one of continuous improvement. We want to make sure that everybody gets their own advice, and you're responsible for getting your own advice in that regard. So before we deep dive into anything else, is there anything else you want to tell us about your career and what you do at Johnson Controls?
Not really. That's pretty much it. So I think I just sort of stumbled into the fire protection industry because started out as a trainee mechanical draftsman, and that particular company was a fire protection company. So the next 43 years I've been in fire protection, but it's been a fantastic industry, and luckily I've sort of worked through a lot of different areas of the business too. So it's been great. But yeah, Johnson Controls is a great company, a very large company, but they've got some fantastic products and great product support. So I've certainly enjoyed working for them for the last 15 years, but got some very good products and some great products coming up as well in the future.
Perfect. Now, I know that you're also involved in the Fire Protection Association Technical Advisory Committee 11 and 22. That covers special hazard systems, which includes foam. So tell us a little bit about that Technical Advisory Committee and how it relates to standards and standards development.
Yeah, so with TAC 11 to TAC 22, I think I've been involved with that for 10, 15 years. So TAC 11 is special hazard, so it covers gaseous suppression systems, kitchen systems, and foam hardware. The other side, TAC 22, covers vehicle systems. So it's basically just a industry group that we work together to help develop Australian standards or provide a working party that can go up to the Australian standards to help update the standards. So I suppose it depends on what we're sort of working at the time. There's a fair bit of time we spent on working on AS5062 update, which is the vehicle system update. Probably more recently, we've been doing a lot of work on the on the foam, because that's a fairly topical subject at the moment with all the changes in terms of legislation. So the technical group has been coming up with some great information bulletins that are available to the general industry on the FPA website. So it's basically just sort of update whatever standards fall due at the time. We've also done updates on the restaurant standard or the gaseous suppression system standard. And we try and meet every other month, and also sort of develop side working groups that help develop those or redevelop those standards as they fall due.
And so how do people get involved in the technical advisory committee if they wanted to get involved, and do they need any special qualifications or experience?
I think obviously having some practical experience would assist, but I think we're sort of fairly open to people joining the committee. Basically put forward your details, and obviously you'd have to have some sort of interest or some sort of background in the products that we're discussing. But no, I think it's fairly open. So it's just a matter of sort of applying to the FPA, telling them that you have an interest in joining the working group or the TAC committees.
So let's frame this conversation, because what we want to talk about is firefighting foam and the history of PFAS, PFOS and PFOA. Perhaps you could give us a little bit of a background on what that all means and what are those acronyms. And I don't expect you to be able to pronounce them all at the top of your head, but perhaps you could just give us a little bit of a background, Dave, on what they are and why there's a bit of a fuss about it.
Yeah, sure do. Look, it's very topical at the moment, and look, I won't pretend to be an industrial chemist. I'll do it in my best firefighting skills. But I suppose PFAS is a group of over 4,200 man-made chemicals. So PFAS, or per and polyfluorinated substances, are chemicals that are used to make fluoropolymer coatings and products to resist heat, oil, stains, grease and water. Polyfluoromer coatings can be a variety of products such as clothing, furniture, adhesive, carpets, food packaging, heat-resistant, non-stick cookware, but they've also used in fire protection. So the fluorosurfactant in the foam gives us the aqueous film formation. So that's basically the element that provides all the performance of the foam. So many PFAS, including perfluorooctanoyl sulfonate, which is PFOS, and perfluoroorganic acid, which is PFOA, are of concern because they don't break down in the environment. They can move through soils and contaminate drinking water sources and build up or bioaccumulate in fish and wildlife. So whilst PFAS chemicals in fire protection is very small when compared to general manufacturing, foam actually represents about 5% of the total fluorochemical usage worldwide. The concern when used in fire protection is the more liberal way in which we tend to use it, in that we discharge large volumes via hand lines, for example, at a roadside accident protecting a spill fire, or in a building fire where it might be difficult to contain the fire water runoff. So restrictions were put in on the use of PFAS chemicals globally, and the fire industry looked at using alternative products that don't contain PFAS for applications where they could contain the runoff. But it's fair to say, like all foams have an environmental impact. So firefighting foams and the fire water runoff have potential to pollute the environment, irrespective of whether they're PFAS or based or non-fluorinated foams.
So does that include the new what's defined as environmental foams?
Yeah, so PFAS foams are basically your AFFFs, your ARAFFFs, and so forth. They're what we call PFAS foams, and then there's the new non-fluorinated foams, or what we call non-fluorinated foam. Others call them fluorine-free. So basically, they've taken out the fluorosurfactant out of the F3 foams, but they do still have chemicals. They still have hydrocarbon surfactants, but it's the key is the fluoro part of it that has the degree of persistence that's causing the issue.
So, what are the applications in firefighting? I know you talked about handheld devices. Are you talking about fire extinguishers, fixed fire systems, fire trucks? What are the different applications of firefighting foam in the fire industry?
Well, pretty well all. So the concern, I suppose, is more for the the brigades where they attend a road accident and they're discharging foam. So the problem is that you can't contain the discharge. So that's why the fire brigades have moved to non-fluorinated products. So it can also be warehouses in foam-assisted sprinkler systems, or refineries or terminals. And we find that where the refineries or the terminals can contain the discharge, where they can treat the spill, they've tended to remain with PFAS-based products, whereas the brigades, where it's more mobile firefighting, they tended to move to the non-fluorinated products.
So, if you're a building owner and you've got a fire extinguisher with foam in it, is that something that you should be concerned about?
Yeah, well, that's the other problem, I suppose. Each state has its own legislation. So Queensland was the first state to come out with its legislation. South Australia followed. So South Australia followed with a total PFAS ban, whereas Queensland allowed you to still use fluorinated products, but they put a total ban on the old PFAS, or the old legacy C8 foams. So each state is different. South Australia introduced their legislation in 2020 and basically gave us a 2-year time frame to phase out. So basically, extinguishers that had to be refilled were refilled with non-fluorinated foam, or they had to be changed out within 2 years. New South Wales, their legislation is a little bit different again. They have a PFAS ban on training and demonstrations, and they've restricted the use of long chain or C8 PFAS foams. New Zealand, they have new legislation that's come in that basically have 2 years to remove all the old C8 based products, or 5 years to remove the C6. So they've effectively gone down the path of having a total PFAS ban. So each state's different. And there's globally, there's different legislation as well in terms of what their PFAS requirements are.
Is there somewhere, and maybe you've got it on your website at Johnson Controls or Ansell, where we can get a bit of a summary of the state-based legislation, what the requirements are? There's a lot of people who'll be watching this will either be people working in the fire industry or building owners and managers. And we want to make sure that we can give them access to information so that they can make informed decisions.
Yeah, so on the FPA, our Industry Association website, there's a very good document that you can download. That's the information bulletin that goes through basically the two sides of the argument. There's also, there's the performance side, and then there's the environment side of the argument. And not everybody sort of agrees, but the information bulletin on foams gives you a very good sort of balanced discussion. It also goes through what the issues are, explains what PFAS is, and goes through the individual legislation or the changes in legislation. I think the working group's actually updating that at the moment because we've had more recent changes with the New South Wales legislation. So if you go onto the FPA website and under the drop-down box for information bulletins, you can get hold of that document. Certainly on our websites that you'll get, there's some good information on our websites, www.ansell.com.au migrate.com. You'll certainly get some information there as well.
I'm just bringing up that page on the information bulletin on my laptop while we're talking. And I'll just share that screen now. So it's pretty easy to find. It was information bulletin number 6, and it's titled The Selection and Use of Firefighting Foam. So I'll bring that up on the screen now, just so people can have a quick look at it. There we go. Share. Oop. Apparently I can't share it on my laptop at the moment, but if you do a Google search for selection and use of firefighting foams, where the word firefighting is one word, you should be able to find that on the FPA website. And you were saying, Dave, that that's something that's being amended at the moment.
Yeah, because we had the sort of recent change with the New South Wales government, their regulations, so that's being sort of updated at the moment. But it's yeah, but it'll go through all the history of the what started all this when we found the traces of PFAS, I suppose, in the old 3M foam, and that was sort of withdrawn. It goes through about the Stockholm Convention, which is developed a position on persistent organic pollutants, or POPs. Goes through, I just got some details here I can run through. Basically, it's an international treaty signed in 2001 and became effective in 2004 to eliminate or restrict the production and uses of POPs. 179 countries signed that treaty, and PFAS was added as a POP in 2009. So PFAS, or perfluorooctanol sulfonate, is what we call PBT, in that it's persistent, bioaccumulative and toxic. So to be classified as a POP, it needs to have all 3 of those elements. So basically, legacy C8 foams with PFAS became listed as a POP in 2009. Octanic acid, or PFOA, has also been accepted for listing as a POP by the Stockholm Convention. So as a result, the fire protection industry transitioned from C8 to C6, or foams with the 6 carbon chain atoms. And this was done in accordance with the US EPA mandate between 2006 and 2015.
So it sounds to me like there's been a fair bit of industry activity around this, and that Australian governments, both federal and state, are also taking action. What is our industry doing in response to the government requirements?
So I suppose most of the manufacturers being, well, certainly our company, Ansell, being a US company, we're sort of locked into that US EPA mandate. So we as an industry had already moved away from C8-based foams to the more environmentally friendly C6 foams. And all the individual states also came on board as part of that Stockholm Convention, as we're a signatory to that Stockholm Convention to promote the elimination of C8-based products. Some countries, I suppose, have gone one step further and gone to a total PFAS ban. So I think all the states have changed their legislation to move away from C8. Our industry group, or the FPA, has been very strong in promoting, I suppose, a balanced debate about what we're doing with foams in terms of our information bulletins. I think the standards that probably need to catch up. We were sort of hoping that the latest edition of NFPA, the national fire, the standard on foams, we're hoping that would come up with some proper guidelines in terms of application rates and so forth for non-fluorinated foams. Unfortunately, the latest version that came out, it didn't. So I think the standards probably need to catch up, because there's probably a bit of a dilemma, I suppose. Our standards say that we need to commission systems and do a total discharge, whereas the legislation says that we can't. We need to contain the spill. So I think the standards need to certainly catch up a bit.
It's in fact, that's one of the last questions I've got on the list, so we can jump down to that. So given that existing firefighting foam systems might contain PFOS, PFOA, I'm going to get all the acronyms wrong now. The AS 1851, so the maintenance standard, requires that we conduct every 5 years a test of the foam after it's gone through a proportioning valve to ensure that it's still proportioned correctly. How the hell do you do that? There's nothing in the standard that tells you how to do it, so that you're not actually having to discharge foam, or is there no solution at this point in time?
Yeah, I think that's what I was sort of getting at. The standards really need to sort of catch up, because the standards still say that we need to do a full system discharge, but what we do need to do is contain the discharge, and we need to take that away as a trade waste. I mean, the NFPA standard, which I'm sort of holding up here, it does, in the appendix, it does give you some alternatives in trying to do like a supplementary test or a test using water. But to be honest, you still need to actually do a test with foam to come up with the baseline data so that you can do the water test. So at this stage, there really no alternative. You have to do the foam discharge, contain the spill, and that needs to be treated as industrial waste.
It's interesting that we're having this conversation because late last year, I worked with one of our clients to test the foam in their systems, and I'll come back to this as an example in a minute. But we had to work out a method of testing the foam, and in the end, we decided that we would capture the foam in an IBC. But as you said, Dave, it's industrial waste after that point, and so even then, we didn't have a clear idea on the best way to process the waste and make sure that it just didn't end up in the environment. It's definitely can't end up in the environment.
No, that's right. And the Queensland government, their foam policy probably goes a little bit further than most, in that it tells you sort of limits in terms of soil and waste, but it says that you have to high temperature or industrial incineration to 1100 degrees C. And there's various companies out there that will take the waste away, but it's basically industrial incineration. I think on the FBA bulletin, it does give you some alternate methods. There was cement kiln. They were looking at using that as part of their feedstock to dispose of the PFAS chemical, but I'm not sure if that's sort of up and running at the moment. But at this stage, unfortunately for PFAS, the only option seems to be the high temperature incineration.
I don't know how it was processed. It was certainly processed by our customer, and I know the company that they engaged to dispose of it. But I, to be frank, I don't actually know what the method was. And just to give an idea, part of the requirements from AS 1851 is to take a sample, and some labs will ask for a litre. There's three different types of foam from the same system, or the same building, same property, of different quality and condition, what these foams are. In fact, interestingly, even though they're all the same foam, they all pass their tests. And so they're examples of what foam looks like when you take it from site. So the challenge for us was, we had to develop some safe handling procedures for our business. What were the requirements for personal protective equipment? It was actually quite a complicated exercise. And in the end, and I'm very grateful for the support of our customer, we were able to test the foam, and in a way that I think was as safe as we could practically do. And we did need to discharge the entire foam through their facility to test it. So we took a sample from the discharge side after the proportioning valve. Now, just talking about those sorts of functions, Dave, if we had an existing foam that had PFAS and we wanted to replace that with a new foam, what is that something is it just a drop-in replacement, or do we have to re-engineer the system, including all of the hardware, to make sure that it works correctly?
Yeah, look, good question. And again, this is sort of touched on in the FBA's information bulletin, but basically, that's not a drop-in replacement. If you look, for example, the foam that you held up, it's typically AFFF. Basically, most of the manufacturers, their AFFF were pretty similar, and in terms of viscosity, it's about 2 to 3 centipoise. So it's basically got the viscosity of, I suppose, milk. The problem is when we go to the non-fluorinated products, we have such a wide range of different viscosities. Some of the very earlier ones, in fact, one of the very sort of popular ones that's still being widely used today, has a viscosity of around about 5,300 centipoise. So you've gone from something with a viscosity of like milk to a product that's now that's like treacle or molasses, very, very thick product. So so certainly the viscosity needs to be considered. One of the things with the PFAS-based products is that we had that fluorosurfactant and it had that aqueous film. So basically that aqueous film was provided all the performance. It spread ahead of the blanket and smothered the vapours. So we don't have that with the new fluorine-free foam. So what is critical is that we need to have a very strong foam blanket, because it's basically the blanket that's replacing the aqueous film to provide that performance. So you need to look at your discharge devices. In some cases, you probably need to go from what we call a non-aspirated branch pipe to an aspirated, because we need to induce more air into the foam solution to help that expansion, increase that expansion ratio. So viscosity, the discharge device, you may need to look at your size of the tank. In most cases, or in some cases, we need to increase the application rate. So the UL 162 standard, which is on foams, has an application rate of 4.1 litres per minute for AFFF. For synthetic detergents, which includes non-fluorinated foams, the application rate is actually 6.5. So gone from 4.1 to 6.5. So you need more foam. We do have non-fluorinated products, and we've actually tested our products to the older AFFF rate of 4.1 and do have listings for that. But so you may need higher application rates. Certainly on some of the polar solvents, where we used to use AFFF, we potentially need higher application rates. So certainly not a drop-in replacement. You need to look at things like your pumps. You know, we're now trying to move fluids that are like treacle. So there's considerations on your pumps. Proportioners. Most of our proportioners, we've had to redo all our proportioners in terms of testing for UL or FM. In most cases, because of that thicker viscosity, the bottom flow rate has to come up higher. So it's a lot easier because we need more energy to get the concentrate moving. The lower flow rate has to be increased. So yeah, certainly not a drop-in replacement. And unfortunately, each application has to be looked at separately, because such a wide variety of systems out there, and foams and risks.
I think that what I'm learning from this conversation, Dave, is that this is not a simple exercise of just swapping over one foam to another, and we definitely need probably higher flow rates and higher pressure rates. Is that right?
Well, potentially need higher flow rates. You'll need, in a lot of cases, you'll need higher application rates. I mean, some of our products have been listed, non-fluorinated products are listed at the same rate as our older products, but not in all cases. So you really need to look at each case on its own. So potentially higher application rates, so it might have an impact on your pumps, your foam concentrate storage, but may also have an impact on your water supply. I mean, if your water supply was marginal with the AFFF system, you're now going to a higher application rate. Your water supply may not be adequate, or your pumps may need to be increased. So it's just hard to make a blanket sort of statement across all systems, because they're all different.
So if if somebody working in the fire industry is not a specialist in the field was looking for advice, is this the sort of advice that they could come to you for? And are there other people in the industry who are specialists in this field that they could talk with?
Yeah, definitely myself, and look, and also the other manufacturers. As I said, download that information bulletin, because it does give you a good overall. It goes through the discussions about viscosity, about application rates, and discharge devices. But yeah, certainly talk to myself or the other foam manufacturers. We can all sort of help you out, help you through that stage. There's certain products that we wouldn't use now for example, base injection. The old AFFF systems we used to use for subsurface injection or base injection, because we don't have that aqueous film in the new products. The non-fluorinated foams are not oleophobic, where they have a higher fuel pickup on forceful applications. So we would therefore not consider them suitable for base injection. So there's other elements that we need to look at as well. Some of the non-fluorinated foams don't work with seawater. Some systems don't work they're not compatible with dry chemical powder. I mean, dry chemical powder is an important part of fire protection, because foams actually work fantastic on surface application, but they're no good for three-dimensional fires or pressure fires. So we need to make sure we use a product that's compatible with dry chemical powders, and not all the new generation foams are compatible with dry chem powders. So, but happy to talk to myself, or certainly all the other manufacturers can guide your customers in terms of what's required and what elements they need to look at. It's
Sorry, Dave, I was just downloading the next slide for our discussion, so you caught me on the hop. What I'm pleased about as an industry is that we've taken some action. I would describe myself as a environmentalist, and one of the things that I like pursuing is in my own business is what happens to something once we've either removed it from service or when we're testing it, so that I make sure that as a company, we're not adversely affecting the environment. And I have young kids, or not young kids, they're all adults actually, but I want to make sure that I leave the world in a better place than I found it, and making sure that we handle firefighting foams in a safe and responsible way is really important to me. So I'm just going to flick to another slide in a second. I just got to upload it, and it's how to contact you. I think probably the best way is if you want to introduce yourself, and well, you've already introduced yourself, but just introduce the best ways to contact yourself. And I'd imagine, Dave, that you work through selected agents for advice and products. Would that be right?
Yeah, so we've got a range of distributors that we sell our products through that can certainly help you out directly. Or I'm also able to assist you technically, but in terms of access to the product, we do that through a series of our distributors, and we've got different distributors in each state. Some focus on the Ansell products, others focus on the CanGuard products, but by all means, drop myself a note and I can sort of direct you to the best distributor in your particular state, or that may focus on that particular product. But yep, there's my details. I probably need to update the photo. I've got a bit more sort of fluff on the face at the moment, but
I think the beard suits you.
Thanks. It's very, very dignified, I think.
If somebody's watching, the QR code is for your LinkedIn profile, which I always think is a good way for people to communicate. I'll just pop myself into here so people can hear me. So if people want to reach out to you, they can via your LinkedIn profile. Unless you want to give away your email address, I'll leave that up to you, Dave.
I can do that. So david.ramsay, Ramsay's RAMSAY, @jci.com.
Fantastic.
Happy to answer any questions.
Well, thank you, Dave, for your valuable time today talking about this important subject on firefighting foams. We do these webinars once a month on or around the second Wednesday of each month. So today is the 15th, so I think that's the second of a full week. We've been doing these webinars now for a fair while. Not all of them have been public. Some of them have been private to our customers, but we decided to make these public webinars. If you would like to learn more about the webinars that we've got a website that covers what's coming up. And I'll just bring that up on our screen now. Switch to that screen. And we'll go turn that off. So you can find more about, here we go. It helps if I can do this properly. Switch back here, edit this scene. Too many things going on, Dave.
Yeah.
I'm still not sure why I'm not seeing that. Doesn't matter. So if you are interested in learning more about the webinar series, next month we're doing a webinar on the introduction of the new Building Code of Australia, which will be exciting. In the month after that, we're doing a expose with the Australian Fire Authorities Council on electric vehicle charging stations within buildings. So we've got a number of customers who've got charging stations and wondering what they should be doing about EV charging stations and fire protection in those areas. So once again, Dave, thank you so much for your time today. It's been really valuable. And again, if people want to learn more, they can either shoot an email to us at hello@firewise.com, or if you visit our website, firewise.com.au, at the top there's a banner that says, here's our monthly webinars. You can check out what we've got going on. There have been quite a few people watching live today, and typically speaking, in the next couple of days, we'll get another several hundred views. So always open to questions, and I'm sure that if anything comes in after this date, or we need to do another deep dive, I'm sure Dave would be more than happy to lend his time. So thanks again, Dave, for your time. I really appreciate it.
For the opportunity to chat about firefighting foams.
Thanks again for everybody watching today, and have a great day.
Nice. Thanks.